is full of wonders. Powerful telescopes show great galaxies scattered throughout space, each containing countless masses of stars. The galaxies slowly rotate over hundreds of millions of years. Some galaxies shoot out jets of gas from their centers where invisible black holes may lurk. Some stars come in large groups, and others in families of 2 or 3 that orbit around each other in a complex dance. Closer still are planets such as Venus that we can explore with space probes, which reveal breathtaking landscapes of craters, valleys, and mountains. In the daytime, we see one star, our own sun, a seething ball of gas. And this is the sun as seen by a satellite that detects X-rays from the storms and explosions on its surface. Nightfall, and the stars come out. A giant radio telescope busies itself detecting radio noise from objects in space. Radio telescopes can work during the day as well as at night. But telescopes that collect light from stars need clear, dark skies, and so astronomers put their observatories on tops of high mountains, above most of the clouds, air pollution, and city lights. The clearest views of all are obtained above the atmosphere. The Hubble Space Telescope is the largest telescope ever launched, and from its vantage point in orbit, it shows the sky more clearly than much larger telescopes on Earth. Satellites in orbit pick up wavelengths other than light that do not pass through our atmosphere, giving us completely new views of the universe. The urge to study the sky is as old as humanity itself. Stonehenge, on Salisbury Plain in England, may have been the first observatory. Thousands of years ago, ancient Britons built this stone circle to follow the yearly motion of the sun around the sky, a simple calendar of the passing seasons that may have told them when to sow their crops, when to harvest them, and when to hold their festivals. The builders of Stonehenge knew the changing appearance of the sky. Every night, the stars wheel overhead as the Earth spins, seen here in time-lapse. This is the full moon, casting its silvery light over the landscape below. Thousands of years ago, the moon was worshipped as a goddess. Now humans have landed on it and found that it is a lifeless ball of dark grey rock. On dark, moonless nights, we can see a faint band of light crossing the sky. This is the Milky Way, and it consists of distant stars in our galaxy. The Milky Way is densest and brightest towards the center of our galaxy, here seen setting behind a tree. Zooming in on the center of the galaxy, we see swarms of stars overlain by patches of dark dust that block our view. Galaxies come in groups ranging in size from a handful to many thousands. Astronomers plotting the position of galaxy groups have found that they form strands around great voids in the universe. Each dot in this diagram is not a single galaxy, but a whole group of galaxies. Distances in space are so great that astronomers measure them by how long a beam of light would take to cross them. Light, which travels at 300,000 kilometers per second, can go 7 times around the Earth in 1 second. To the Moon and back in 2.5 seconds. Over 8 minutes from the Sun to the Earth. 5 hours from the Sun to the most distant planet. 4.3 years to the nearest star. From our Sun to the center of the galaxy takes 30,000 years. To cross the galaxy from one side to the other takes 100,000 years. From our galaxy to its near neighbor, the Andromeda galaxy, takes over 2 million years. And to the most distant objects visible in the universe, called quasars, would take 15 billion years, over 3 times the age of the Earth. The distant region of the quasars is of particular interest to astronomers studying the origin of the universe. Quasars are thought to be the intensely brilliant centers of young galaxies, seen shortly after the universe was born in a giant explosion called the Big Bang. In 1992, a satellite called COBE, the Cosmic Background Explorer, detected traces of heat left over from the Big Bang itself. The Big Bang occurred about 15 billion years ago. In one incandescent moment, the universe erupted into being. It began to expand from a microscopic dot to the vast size we see today. Over time, the hot gas thrown out from the Big Bang explosion began to condense into stars. Some of these ancient stars still exist in spherical clusters around many galaxies, including our own. Our galaxy is shaped like a gigantic Catherine wheel. The oldest stars lie in the globular clusters and also in its center. Its outer arms contain young stars, including the Sun, and dark clouds of gas and dust. This is a galaxy like our own, seen edge on, showing dark clouds like those that mottle the Milky Way. If we could see our own galaxy in a distant aerial view, it would look something like this impressive spiral. But galaxies come in other styles too. This shapeless scattering of stars is a dwarf galaxy, little more than a loose star cluster. Two small galaxies, called the Magellanic Clouds, accompany our own galaxy, and this is the larger of them. This small spiral seems to have been pulled out of shape by the gravity of a passing galaxy. Some spiral galaxies have a straight bar of stars and gas across their centres. This strange object is thought to result from the merger of a giant elliptical galaxy and a spiral galaxy, which has introduced the lane of dust. Here is a normal giant elliptical galaxy. Pink clouds in the arms of spiral galaxies are clouds of hydrogen gas called nebulae, from which new stars are born. Here in close-up are fields of bright nebulae in our own galaxy. These dark streaks are clouds of cold gas and dust, seen in silhouette against the brighter gas which is lit up by the hot young stars born within it. Other types of nebulae mark the end points in a star's life. Here are the remains of a star that ripped itself to pieces in a supernova explosion in the constellation Cygnus. This dying star lost its outer layers in a celestial smoke ring that surrounds it, like a wreath on a grave. This family of hot young stars, called the Pleiades or Seven Sisters, is still surrounded by traces of the nebula from which they formed. Within this foggy nebula lies Antares, the brightest star in the constellation Scorpius, the Scorpion. Antares is the type of star known as a red supergiant, a bloated sphere of gas 400 times the diameter of the Sun and 10,000 times as brilliant. This is how it might look from close up. Stars are gigantic nuclear reactors, turning hydrogen into helium at their centers, and it's the energy released in this process that makes them shine. Like all stars, Antares began its life when a cloud of gas and dust shrank and heated up and began to glow. A star as massive as Antares would at first have been hot and blue, like the stars in the Pleiades cluster. Then, as the star got older, it would swell up and turn red as we see it today. Eventually, when it's used up all the fuel at its centre, it will explode as a brilliant supernova, scattering its outer layers into space, but possibly leaving behind a tiny, fast-spinning core known as a pulsar, with as much mass as our sun squashed into a ball smaller than a city. A pulsar gives out flashes of radio waves every time it spins, like a celestial lighthouse. But sometimes, if the star's remaining core is heavy enough, it'll shrink down into something far smaller and denser even than a pulsar, a black hole. Black holes are drain plugs in space from which nothing can escape, not even light. However, gas can be drawn into the otherwise invisible region. Some black holes orbit around normal stars. Here, gas is torn off the visible star and flows towards the black hole. As it plunges towards the hole, it heats up to millions of degrees and emits X-rays which can be detected by satellites in space. Most stars are not single like our sun, but come in families like this pair of stars, orbiting around their common centre of gravity. In this example, a normal star is orbited by a small white dwarf. Gas from the larger companion overflows onto the white dwarf, where it builds up and explodes from time to time, producing what's called a nova. The whole process can repeat itself many times. Dark dust clouds like this prevent us from seeing to the centre of our galaxy. There are many examples of obscuring dust in other galaxies too. However, wavelengths other than light can pass through those intervening dust clouds, and radio astronomers have mapped the regions of the galactic centre in Sagittarius, 30,000 light-years from us. This swirling region, shown on a colour-coded radio map, may be evidence for a massive central black hole in our galaxy, swallowing stars and gas around it. Black holes are now thought to exist at the centres of many other galaxies where, rather than swallowing gas, they're spitting out jets of it in opposite directions. With the naked eye, we can see a few thousand stars, 5 bright planets, including the brightest of them all, Venus, seen at centre right, and in the southern hemisphere, 2 nearby galaxies called the Magellanic Clouds, at lower left and top right. The most distant object visible to the naked eye is the great spiral galaxy in Andromeda, over 2 million light-years away. But our understanding of the universe only began to develop with the invention of the telescope in the 17th century. Early telescopes, like this one used by Galileo, used a lens to gather light. This is a larger version of the same idea. A rival design that uses a mirror soon became popular because they could be made much larger and hence collect more light. and it's mirror-based telescopes that are most widely used in astronomy today. The large main mirror collects incoming light and focuses it via a series of other mirrors onto sensitive instruments that record and analyze the light. Observatories are sited on high mountains and contain an army of telescopes. A large telescope can be pointed precisely at any spot in the sky and track it as the Earth spins. New designs, such as the giant Keck telescope in Hawaii, use mirrors made of many separate segments. These are some of its first pictures of nebulae and galaxies, artificially coloured by computer to bring out details. The Keck telescope has a mirror 8 meters across, but by the end of this century, an even more powerful instrument, with 4 telescopes of that size working in unison, will be in operation at the European Southern Observatory in Chile. Radio astronomy is also a vital part of our understanding of the universe. This is a huge radio telescope built into a saucer-shaped depression between hills on the island of Puerto Rico. But most radio telescopes look like this, a giant metal dish to collect radio waves and focus them like the mirror in an ordinary telescope. The output from several different radio telescopes can be combined in a computer to produce far more detailed views of the sky than would be possible from one dish alone. Radio telescopes allow us to view obscured objects. For example, this region, deep in the central hidden core of our own galaxy. This combined picture shows an optical view of a galaxy flanked by twin clouds of gas many times larger, normally invisible, but detected by radio telescopes and shown here in red. These jets of gas, artificially coloured, are being shot from a disturbed galaxy, possibly the result of a central explosion. As well as detecting radio waves given out naturally by objects in space, radio telescopes can be used in reverse to beam out strong signals to nearby objects and detect the echoes, interplanetary radar. This is a radar picture of a double asteroid, 2 lumps of rock orbiting the Sun side by side. Astronomers learn more about the universe by observing at a wide range of wavelengths. This is our own galaxy, seen at infrared wavelengths by a satellite clearly showing the bulge at its centre. Other satellites observe at shorter wavelengths. This is a view of our galaxy in ultraviolet light emitted by hot gas and stars. Seen in X-rays is a cluster of galaxies enveloped in a cloud of thin gas, shown in pink. From views such as this, we know that there is much more in the universe than shows up on normal photographs. Also in X-rays, here is the Sun, its surface racked by fiery eruptions, rotating in a month as seen by a Japanese satellite, with a normal view at right for comparison. Most famous of all the orbiting observatories is the Hubble Space Telescope, which, despite a fault in its mirror, has shown us the universe in more detail than ever before. Like a telescope on Earth, Hubble's large mirror collects faint light from distant objects and bounces it into a series of instruments behind the main mirror, including an electronic camera that takes remarkable pictures. Homing in on the Orion Nebula, it spotted plumes of gas streaming at high speed from newborn stars and shells of dust around young stars. Here's an expanding shell of gas puffed off from an aging central star. Another ring of gas, this time ejected from a star before it exploded as a supernova in the Large Magellanic Cloud in 1987. Here is a new view of the blast wave from a supernova that went off in the constellation Cygnus thousands of years ago. Now a gigantic storm around the equator of the ringed planet Saturn, carried around as the planet rotates every 10 hours. A knotted ribbon of gas shot out by violent processes at the center of a huge elliptical galaxy. And a portrait gallery of the different types of galaxy that inhabit the distant reaches of the universe. Astronomers are now finding numerous examples of spectacular traffic accidents in the universe as galaxy meets galaxy. This distorted object, for example, probably results from such a near collision between galaxies, as can be seen if the process is run backwards in computer simulation. Computers can model such galactic encounters. Here, two spinning galaxies approach each other. Streams of stars spray out as the two galaxies rush past each other, their shapes distorted by the close encounter. These Hubble photos show distant galaxies passing close to each other, and perhaps even about to merge to form a supergalaxy. This process could be the secret of galactic evolution. This spiral of bright young stars lies at the heart of a pair of galaxies that are uniting. The burst of star formation that created this spiral was probably triggered by the collision. Even the familiar Andromeda galaxy, the nearest spiral to our own, shows signs of having cannibalized another galaxy. Through telescopes on the ground, it appears normal. But under Hubble's closer scrutiny, first one, then another center appears. One of them, the remnant of a smaller galaxy, swept up 1 billion or so years ago and now absorbed almost without trace. Hubble has given new insight into the violent processes happening at the very centers of galaxies. For example, this giant elliptical galaxy in the constellation Virgo, first seen in an optical picture, at radio wavelengths we see immense gas jets either side of it, spanning over 80,000 light years. When Hubble zoomed in on the spot from which the jets arise, it found this glowing ring with a bright hub. Computer simulation shows what's going on. A swirling ring of gas and dust feeding a central black hole, which compresses and heats the gas, squirting some of it out to create the radio jets. The central black hole has an estimated mass 10 million times that of our sun. If we fell into it, we would vanish forever. Our sun was born about 5 billion years ago. About 4,600 million years ago, a cloud of dust and gas in our galaxy collapsed to form a new star, our sun. Around the young sun, a disk of leftover gas and dust gradually collected into clumps. These became the 9 planets, including the Earth, that make up the solar system, all in orbit around the Sun. In the past 3 decades, space probes have explored all the planets in the solar system, except distant Pluto. Among the most successful of these probes have been the 2 Voyagers, launched to study the outer planets. They were launched from Earth in 1977 on a journey that was to take many years, first flying past giant Jupiter, and then Saturn, the planet with the bright rings. The second Voyager then went on to look at the remote and mysterious planets, Uranus and Neptune. Their job's done. Both Voyagers are now heading out of the solar system forever and into the galaxy, interstellar emissaries from the planet Earth. Who knows whether they may one day be intercepted by some alien civilization, if any exist out there. In order of distance from the Sun, the 9 planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. The only one on which life is known to exist is Earth. The 4 planets closest to the Sun are small and rocky. The Earth, seen here at lower right, is 3rd in line and appears blue because of its oceans. Further out are 4 large planets of gas and liquid. Jupiter, top right, is the largest, and Saturn, with its rings, the most beautiful. Pluto, lower left, is a small icy oddity at the edge of the solar system, orbited by a moon half its own size. The hub of the solar system is the Sun, an ordinary star 100 times the width of the Earth. Energy is released from the nuclear furnace at its center and flows out to the surface. Seen in X-rays, the Sun is continually racked by storms and explosions. Each bright spot is like a cluster of hydrogen bombs going off. In close detail, the Sun's surface seethes with tiny bubbles of hot gas rising to the surface like water boiling in a pan. Larger, dark patches are sunspots, areas of cooler gas, each one large enough to swallow the Earth many times over. A total eclipse. The moon covers the face of the Sun, blotting out its light, and around the Sun's rim, a misty halo of faint gas comes into view, called the corona. With the Sun's glare obscured, huge glowing clouds of gas, called prominences, can be seen arching into space around the Sun's rim. They dwarf the Earth. Filmed in close-up, in the light from hot hydrogen, brilliant explosions called flares rip across the Sun's surface, sending out streams of atomic particles that affect the weather on Earth. When the atomic particles from flares reach the Earth, They cascade down onto the atmosphere to cause a glowing ring around the magnetic poles. Seen from below, this colourful atmospheric glow is known as an aurora. Mercury, closest to the Sun, is the smallest planet apart from Pluto. It's an airless and waterless ball of rock, only 50% bigger than our own moon, which it closely resembles in appearance. In 1974, it was visited by the space probe Mariner 10, which took these close-up pictures of its cratered surface, scarred by meteorites that have battered it over billions of years. On this hostile surface, blasted by lethal doses of high-energy solar radiation, daytime temperatures rise high enough to melt lead. Venus, the brightest planet in our night sky, is the Earth's twin in size, but very different in other respects. Clouds of yellow sulfuric acid shroud its surface from our view. But radar can cut through the clouds, revealing meteorite craters, volcanoes, and valleys. This computer-generated ride over Venus was assembled from radar images taken by a space probe in orbit around the planet. The roughness of the surface has been exaggerated to emphasize the features. Sulfur clouds cast an eerie yellow glow over the landscape. Under the dense atmosphere, temperatures are as hot as an oven and the pressure is crushing. Nothing could live on Venus. The Moon, seen here in a computer-simulated flypast, is the Earth's nearest celestial neighbour. Meteorite craters and dark lowland plains scar its grey and lifeless surface, which has scarcely changed for billions of years. What a contrast with the Earth, a welcoming world of blue oceans, white clouds and colourful continents. There's Australia, Africa, and South America. Here, photographed by a space probe called Galileo, is the first ever view of the Moon moving around the Earth. Let's see that again. And here, also from Galileo, is a close-up of the rotating Earth. Note the sun's reflection off the Pacific Ocean and from rivers and lakes in Australia. The Moon is so large in comparison to the Earth, about 1/4 its size, that some astronomers think of them as a double planet. Mars, half the size of Earth, is covered with dusty red deserts. Dark markings on the planet were once thought to be fields of plants, but are now known to be simply outcrops of rock. Space probes have landed on Mars to search for life, but found nothing. Mars has 2 white polar caps, much thinner than the polar caps of Earth. Space probes have mapped Mars from orbit, revealing giant craters, volcanic mountains, and a rift valley long enough to span the United States. This flight over Mars was generated by a computer from space probe photographs. There's the Rift Valley below us. Here's a volcanic peak with a huge crater on its summit. And there are 2 more, all in line. Now we're about to go for a ride along the Rift Valley on Mars. Mars has 2 tiny moons, looking like lumpy potatoes. The bigger one is called Phobos. The other is Deimos. They're thought to be stray members of the belt of asteroids that lies beyond Mars. In 1991, the space probe Galileo passed through the asteroid belt and photographed one of these rocky bodies named Gaspra. In close-up, it looks like the head of a shark. This comparison with Phobos and Deimos shows how similar they all are. Jupiter, the largest planet, 10 times wider than the Earth, is wrapped in colourful bands of ever-changing cloud. The only permanent feature is a huge oval called the Great Red Spot. Beneath the clouds of Jupiter is an ocean of liquid hydrogen. In this Voyager sequence, the Great Red Spot reveals its nature as a spinning storm, large enough to swallow several Earths. Jupiter has 16 known moons. 4 of them are big enough to be considered as planets in their own right. Io, innermost of the 4, has a weird landscape of orange sulfur erupted from volcanoes that dot its surface. Europa. Its icy surface cracked like an eggshell. Ganymede, the largest moon in the solar system, bigger than the planet Mercury. Callisto, peppered with bright impacts. Beyond Jupiter, Saturn, second largest planet, ringed by countless chunks of ice and rock. Voyager skimmed the outer edge of the rings. Saturn's atmosphere lacks multicolored storms like those on Jupiter because high-altitude haze obscures them. But computer processing and artificial color brings out subtle cloud details that would otherwise remain unseen. Saturn's rings, at first sight like smooth sheets, broke into thousands of narrow ringlets under the close scrutiny of Voyager's cameras. Again, the colors are added by computer. Here, two small moons orbit either side of a ringlet. And here are dark patches on the rings, caused by overlying clouds of dust. Saturn has more moons than any other planet, at least 20 are known. Largest is Titan, with an atmosphere denser than Earth's. Smoggy orange clouds obscure its surface. The meteorite that dug out this huge crater on Mimas must almost have shattered the little moon. Whereas Enceladus has smoother areas and strange grooves. Uranus and its rings presented a bullseye appearance to Voyager. The planet was toppled on its side by a gigantic collision long ago. Voyager's first pictures showed only a featureless blue disk, but computer processing revealed cloud bands around the pole that points to the sun. And here, in time-lapse, is a ribbon of white cloud being carried around anti-clockwise by the planet's rotation. Voyager discovered several new moons around Uranus and took a closer look at those already known from Earth, such as Oberon, splashed with bright rays from meteorite impacts. Umbriel, a dark moon with a bright crater seen at the top of this picture. Titania, the largest moon of Uranus, has cracks and grooves in its surface that bear witness to movement in its crust. As does Ariel, where the valleys are even more prominent. Most fascinating of all the moons, though, was Miranda, a body with such a jumbled surface that it looks as though it has been broken apart and reassembled again. Among its features is this steep cliff, 20 kilometers high. And as it passed Uranus, Voyager looked back at the thread-like rings that girdle the planet's equator. Voyager's final port of call was Neptune, another blue-coloured planet with narrow rings in the dark outer reaches of the solar system. From here, the sun appears only as an intensely brilliant point of light. One target of special interest for Voyager was Neptune's largest moon, Triton. Voyager's pictures are the best views we're likely to get of Neptune for a very long time. This dark cloud is Neptune's equivalent of the great red spot on Jupiter. A Neptunian storm cloud with a bright center like an eye. Ribbons of white cirrus. Voyager homed in on the faint rings of Neptune. Here, the planet's bright globe has been blocked out to show the rings better. This moon, Proteus, was discovered by Voyager. It's Neptune's second biggest. Nereid, a moon known from Earth, was seen only from a distance. But the star of the show was Triton, an amazing moon with pink and blue ice fields. Pluto, only discovered in 1930, is never well seen from Earth. This is the best Earth-based view of the planet and its moon, Charon. The Hubble Space Telescope shows them separately for the first time. Pluto is an icy body, smaller than our own moon, and probably similar to Neptune's moon, Triton. Its moon, Charon, is half its own size, and at times the two can eclipse each other, as in this simulation. Comets are snowballs left over from the formation of the outer planets. They move around the sun on highly elongated orbits. This is the orbit of Halley's Comet, which orbits the sun every 76 years. When a comet nears the sun, it warms up, releasing gas and dust to form a long, flowing tail, as did Halley at its last approach in 1986. On their way out of the solar system, the two Voyagers are still sending back information about the space around us. They're now approaching the boundary of the solar system, called the heliopause, where the gas flowing out from the sun finally meets interstellar space. Eventually, we'll lose touch with the Voyagers as their radio signals fade out with distance. But it has been calculated that 40,000 years or so in the future, one of the Voyagers may pass within sight of a dwarf star in the constellation Ursa Minor. If we could ride on Voyager with a telescope, this is what we might see. By then, of course, humans might already be out exploring among the stars. Their first call would be at the star closest to us, Alpha Centauri, which actually consists of twin sun-like stars in mutual orbit, accompanied by a smaller and fainter red dwarf, Proxima Centauri. There are no planets around Alpha Centauri that we know of, but astronomers think that other solar systems may be common. The wings either side of this star are thought to be a band of dust and gas forming into new planets. The star itself has been blocked out, and the colours are artificial. This computer simulation shows what the star might look like close up. Planets are thought to be forming from the spinning disk, like they did around the Sun. New stars are being born all the time in places such as the Orion Nebula to replace those that grow old and die, as our Sun inevitably will. Our Sun began shining nearly 5 billion years ago. During that time, intelligent life has arisen on Earth. Currently, the Sun is in stable middle age. But when its hydrogen fuel starts to run out in a few billion years more, it'll swell up into a red giant up to 100 times its present size, swallowing the inner planets and ending all life on Earth. As it dies, the bloated Sun will lose its outer layers, and its remaining core will shrink down to a tiny white dwarf. Like the one at the center of this nebula. Even 5 billion years from now, when the Sun has died, there will still be plenty of new material to make more stars in nebulae such as these. And what will be the fate of the rest of the universe? Astronomers are now discovering a remarkable fact. The visible galaxies represent only a small fraction of the total mass of the universe. Most of the mass of the universe is contained in the form of dark, invisible matter that does not show up on photographs. If there is enough of this dark matter, its gravitational pull could affect the fate of the whole universe, slowing down the current expansion and eventually reversing it so that all the galaxies fall back together again. Perhaps, billions of years in the future, there'll be another Big Bang, creating another universe with lots of new wonders to explore.